So we are pressed in time, and with that, I think we should just start, and everybody else that finds this session interesting will come in later. Welcome to all of you to the Electrification of Heat session. We have started, or IRENA has established this session because heating and cooling is responsible for 50% of all energy demand in Europe, but also across the world. And for Europe, that means 6,000 terawatt hours of energy, and 3/4 of that is done by fossil energy. So if we want to green the heating sector, probably the fastest inroad into that, the fastest vector is by electrification, as we have seen this morning, and that's also an expectation of the IRENA roadmap. We can say for Europe now that 30% of all electricity is already from green sources. In heating, it's only 19%. In total terms, actually, it means still that more heating is coming from green sources than electricity. But that may be a challenge and an opportunity at the same time. So we see that with this speed of greening of electricity comes a reduction in costs, and there is a lot of improvement in competitiveness. And that's actually what we want to discuss today. What is the impact of this reduced cost on the development of both sectors, on the coupling of both sectors, coupling of electricity and heat? And I hope that the session is enlightening and will show us what can be done. We'll also talk about the feasibility of the efficient electrification, about the challenges and opportunities. So please welcome with me the panel of experts. I told them before that they shouldn't talk too much about what they are doing because they are all here because they are distinguished experts in their field. So they're really great in what they do. If you want the details, talk to them afterwards. Today we should talk about the efficiency of electrification. And my name, as you can see here, is Thomas Nowak. I'm the Secretary General of the European Heat Pump Association. By definition, we are very happy with an electrification of heat. But of course, we also know that there is challenges involved. Having said that, I would like to welcome Wolfram Spaber, who is the head of renewable energy at Eurac Research. He will give an overview presentation first. And the way we set this up is that after each presentation, there will be a few questions or comments by the panel on the presenter's perspective. And after we have done 4 presentations, we will open the floor to you. You can, at the same time, while the presenters present, already ask questions with the Attendify tool. You will not see them immediately, but they will show up later. The second speaker is Torben Funder Christensen. He's representing Danfoss. He's the head of public affairs, and he will give more system integration perspective, and then again a round of questions and comments, followed then by Martin Hagen, who is, in my wording, representing the thermal alternative. So if we cannot electrify everything, what can we do with thermal energy, especially in an industry setup? And we will close the presentations with Avi Brennmiller, who will give a quite specific technologies presentation on the importance of storage, and that will open up the discussion also on the importance of storage, because if we electrify with variable renewable sources, what do we do in these notorious nights when there is no wind? And I hate the term, but anyhow, we have to overcome and have to find solutions. And then we will be joined by a distinguished panel of other experts, 2 from research, Guy Wegmans from Vito in Belgium, and also a contributor to Energyville, a very interesting setup and cooperation on how to reduce the energy demand in cities. Then Monica Axel from the Swedish Research Center, RISE, and also very active in the IEA heat pump program. And then there is a bit of a more international perspective by Degar Saygan. He is the director in the Turkish Energy Transition Center, and truly international, and probably deserves the prize for longest travel on this panel today. Wei Ling Xiao, Vice Director of the Ministry of Sciences and Technology for the Chinese State Grid. Welcome to all of you. I will not waste any further time. Wolfram, please provide the overview, and then we can jump into the discussion.
Thank you very much, Thomas, for this kind introduction. So there was a misunderstanding. My presentation is a bit long. That means that in order to keep timing, I will fly over that and just, let's say, stop at some specific points which I would like to bring forward to you as starting points for discussion. So don't see it as a presentation where we go deep into something, but more to fly over aspects and give us food for thought afterwards. So it would be nice if I could see in the screen in front of me as well the presentation, or not to have to turn around. Thank you. To myself, I'm heading an applied research center, and that is one foot I'm in, and the second foot I'm in is actually I'm sitting in the board of directors of a regional energy utility. Sorry, I've got some problems with this one. Where's the sensor for that one? Oh, that's going to be difficult. Okay. So let's say from that point of view, we're producing renewable energy. We are the third largest renewable energy producer in Italy, and I would say I get a little bit of an economic insight about the whole thing. So, sorry, this is a bit difficult. So basically, two issues we are talking about is climate change on the one hand, and urban air quality on the other side. Okay. Yeah. Are you ready? Okay, so I'm getting up with my fingers. It's going to be many slides, so you have to be fast. I kindly ask you to run, okay? All right, so heat pumps can be the solution, so that's the question, because they're widely renewable and there are no emissions which are set out on site. So we might think heat pumps are the solution for all our heating issues. So in order to understand if that is the case, I would like to bring you to a journey where we look at the overall energy system. In this case, I'll take you to a detailed simulation which we did for a regional case. And we looked at the fact if the climate target of that region, South Europe, the region where I come from, is actually achievable. The climate target says 1.5 tons CO2 emission by 2050. And so we looked obviously at the actual energy consumption, as Thomas said, where heating and cooling is dominating. Heating is more than around 50% of the overall consumption. And what we did is went very deep into it. So we got hour by hour over a whole year through the thermal consumption, through the electricity consumption, considering on the one hand the production side, on the other hand the consumption side, and simulating a whole series of models through in order to understand how, let's say, what kind of energy system which is demanding the requirements is emitting how much CO2 emissions and is costing how much of the overall cost side. So what does it mean? Obviously, that means that you have to know the potential on each single sector, in hydropower, in PV, in wind power, in storage technologies. You have to understand what kind of resources do you have available on the biomass side, for example, on the solar thermal and on the heat pump side. And we went very deep into the building sector to understand what is the efficiency curve we can go through. So that means that we try to understand how many building of what years, of what kind, of what size do we have located, how many walls do we have, how many roofs do we have, how many square meters of windows do we have, how much does it cost to refurbish a different kind of buildings with a different sector, in order to go in a detailed analysis of what it costs to change this kind of energy system. Obviously, we had to look at the transportation sector because it's very important for the emissions, and we feed all that in a model, and we optimized the model and went through 25,000 simulations. And to make it very short, what you can see and what comes out is a whole cloud of solutions. And what you see as the first thing is actually that in regard to the point RS, which is the reference scenario where we are starting from, for the same cost, you can have other energy scenarios which emit much less CO2 emissions and do not cost more as we have today. But if we want to reach the target which was set, so it's 1.5 tons per CO2, considering only the heating and electricity sector, we do not reach the target. We reach only 2.5 tons per person. So that means that we have to electrify, or we have to bring to zero emission as well the transport sector. And if we do that by direct electrification, we see on the one hand that we can go further down. In this case, let's say 20% electrification, 40% electrification, more than 50% electrification in order to reach our target. So it means that on the one hand, it is reachable. On the other hand, we have to massively electrify our sectors and to bring them. So if you look at the overall situation, what does it mean? It means that the heating sector or the building sector has to be massively intensified and refurbished, so that energy consumption is going down. The transport sector is being electrified widely. That means that the overall energy consumption goes down in a very strong way, while the electricity consumption goes up. The electricity consumption in a relatively way goes over 50%. In absolute numbers, it goes in this case from 2.8 terawatt hours to 3.5 terawatt hours. So, conclusion for the model, yes, there are different energy systems which are possible to meet their targets. It leads to strong reduction, and the financial data are actually similar, but just for your information, this is a side part of it. If you look at it from a regional perspective, it changes strongly. So the overall cost is similar, but the added value in the region, obviously in a low carbon model, is much, much higher. We're talking about several hundred millions more added value per annum to the region, because you actually invest in a local energy efficiency and renewables on site instead of spending it out on fossil fuels. So what does it mean for our discussion of today of electrification of heat? If we look at the heating demand side curve and the electricity demand side curve, in this case of that region, we see what you see on the left graph. If you look at that for the Italian case, it is very similar. Though overall Italy obviously is longer and is hotter. Nevertheless, the difference between electricity and heating side is different. So you might ask, well, that's no problem, because we've got heat pumps, and with heat pumps we have a COP of 4, 5, 6. So that means that even if my electricity curve is much lower, I can come over that gap in the heating side, which might be true. On the other hand, if you look at the functional curves of heat pumps, we know that the independence of the outside temperature, of the temperature gap which you have to overcome, the efficiency goes down. So in the moments where you actually need most heat, the efficiency of the heat pump is going to be the lowest. Or if you look at the frequency of the utilization of heat pumps, you see that you have a certain distribution over the year where you are with 4 or 5, let's say, the main point, but you have as well moments where you have a high efficiency and moments where you have a low efficiency. So how can we deal with that? That brings me to the point that in order to actually overcome that problem, we have to see it in a context, and we have to work on different issues. And actually what we have to do is to make these two curves closer. This is the case of Austria. The shape is very similar of the heating demand side and electricity demand side. So that means on one hand, we probably get up with the electricity demand side, we're going to use more electricity. But on the other hand, we have to massively push down the heating demand side. So that means that we have to largely refurbish the buildings. And on the other hand, we need to couple, or let's say if they are going strongly renewable, probably we need to couple in a strong way the two sectors. And coupling means on the one hand, so what I said, refurbishment of buildings on the one hand, and on the other hand, utilization of local available resources, of cogeneration, coupling on the one hand, of thermal storage on the other hand, and of coupling through heat pumps on the third hand. So looking at evolution of systems, this is a figure from Euroheat and Power. Basically, you see the district heating systems, how they can evolve from purely fossil and purely heating to integrated systems based on renewables. Or if you look at it from another point of view, it might be to a trend to low district, to low temperature heating systems where heat pumps play a relevant role. But on the other hand, you can as well include in a very strong way waste heat, which is another big resource of that. So I'm jumping over the closing remarks, which might be up for the questions. I think the presentation is available for you. So if you have interested in literature or projects or just a book which is coming in the shelf in these weeks, the information is there. Thanks for your attention. Sorry.
Well, thank you, Wolfram, also exactly for keeping the time, because originally he had 62 slides. So you see that we can speed through. And that is actually what brings me to the first question. And the way we want to do it, I will ask one question and then I ask for comments from the panel for each presentation. Do you think the speed of change is as fast as you have been presenting these solutions?
I think it is, and interestingly, it was especially, or it is especially in the power sector. This is something that my feeling is that the power sector was faster or is faster than several other sectors. And in fact, what I wanted to highlight, the building sector, which I see as really important. I've got a feeling Europe has not found yet the key how to unlock the possibilities, how to refurbish it in a massive scale. So we are, while I have the feeling that in the power sector we are on track, on the building side, I have the feeling we are not on track yet.
And maybe then an add-on, in your simulations, did you consider any technological breakthrough, or can I assume that you built all this on available technologies? And that's also which will open the questions to the panel. So if you have any comments, please raise your hands and then you can continue.
Yeah, you're right. We did not consider, I don't know, nuclear fission or any of these technologies to come up in a large scale. We based on actual technologies that we know, that we have, and on very conservative trends that we see. Where we're not confident on trends, we just keep the same numbers as we have today.
Is there any comments here from the panel on what you have seen so far? Any of your own work that relates to this? Yeah, then we have two. Martin, yes, please just take the microphone. No. Can you switch on the microphone, please? In the middle. You just take it.
Yeah. I have one question. In one of the slides of the results, you mentioned that industrial heating is not included, at least in the order of magnitude. Have you a rough estimation how things would evolve?
Well, we did not include it. Yeah, one step back, electricity figures are very clear and very precise. So in most countries, you just ask the TSO and you get very detailed numbers about that. Heating figures is much more difficult to get because the source is different, the transformation is difficult, and so on and so forth. So we did quite a work in order to understand how the figures can be, and they are still estimations from our side. So we tried to be as precise as possible, but they are still estimations. The industry, we did not put it inside, so let's say not in these graphs, we elaborated them as well, and what we assume is basically what industry brings is just to shift upwards the whole curve, because the industry, obviously, production processes are more constant over the year, so you have not a big consumption peak in winter time, and therefore it's just an upshift by 10 to 15% to our estimations of the whole curve in the Italian case. Obviously, that depends from country to country.
The building sector is not on track at the moment. I strongly believe if we can't build a stronger collaboration between the building sector and the supply sector, power sector. Do you have any ideas how we could make this in order to accelerate the transition?
So I think one of the elements of the power sector is that you have some actors which can, let's say, put in big numbers on place. And that is somehow the difficulty of the building sector, that if every single building has to decide and every single apartment has to decide that we are contributing to refurbishment, I think it's going to be very difficult. So in my opinion, if we are not able to find ways where actually external money, financiers, investors, utilities, whoever is taking over their job and doing it and financing it, I think it's going to take us a century to refurbish.
Yeah, I just wanted to ask you actually, and it's good that you raise your hand. From the work that you do at Vito, would you echo what Wolfram and Monica and Martin have said?
Well, indeed, I think the electrification is not yet at speed. It's only beginning. But we see some examples, and I think the refurbishment of larger stocks of building is now changing with some industrial actors. We have, for the moment, we have a project that we are doing together with the Netherlands, which is called Renovates, Ren for renewable and Novates for the renovation. And 250 housings were, in fact, dwellings were, in fact, refurbished on a very short term from gas-fired to full electric. So this is in a few days. The complete building is being refurbished. You have a heat pump, you have an electric boiler, you have even some battery storage was included. And the main issues is, well, first of all, it has been proven that it is technically feasible, so that it is feasible in a short time, the refurbishment, that you have a good interoperability between the different components, which is, of course, very important, and that people are also, well, they are interested. That's very important, because what, for instance, that project did was it did not only refurbish the heating system, so with the heat pump and so on, it also refurbished the electric appliances, dishwasher, and so on. And this is another aspect where you are going from a service which is not only offering heating comfort or cooling comfort, but also offering a general living comfort. And that's the step that is being made by some companies, and I think we're at a phase where this is going to be replicated, and examples are that showing that it is feasible.
Okay, we have another one, but now we have to be brief, right? So I want to, did you look into the value of flexibility? Because I think the value of the demand side on how you basically remunerate the users of flexible electricity, that is a main driver for the implementation and the innovation in the market.
So we did not from an economical point of view. Obviously, it is absolutely, I agree with you. This is going to be very interesting, and we are working on that issue. So I'm very curious to see how that works, and I think it will have a big change as well on the production side when you have a much more active demand side. What I think is interesting, and then I stop, is just the aspect of electrification of transport, actually, which I personally did not expect. We saw in our curves that we have more than 50% of electrification, which leads us only to more plus 19% in the electricity consumption, and to interesting storage side.
Okay, I know, but you have to be very brief. Avi, and then Derek, and then we continue with Robin.
Okay, so we are all assuming using existing technologies and building the future to 2050. I think what will happen is in many cases the numbers won't work and things won't happen. So we have to assume and integrate new technologies. And another comment, we are talking a lot about electrification, but if you add the home appliances, as you did, to the demand, you will find out that 60, 70, up to 80% is heating and cooling. Yes. And we are all talking about electrification. So at least on the local arena, where your home, your neighborhood, it all has to be transferred to heating and cooling. So one has to think about integrating. Maybe you transport the energy through electrification from the renewables, but eventually have to store and use it around the clock locally on a heating and cooling basis, and not just electricity.
Okay, we keep that in mind, and we have it on video. Degar?
Okay. This works. Okay. I wanted to give an example of some recent news from the Turkish perspective. The urbanization rate is around 2% a year in Turkey, and 4% a year the building stock is growing, which creates significant potential for actually electrification. And we have an earthquake-driven program called the Urban Transformation Plan, which aims for hundreds of thousands of buildings to be rebuilt. So a very fast renovation speed is being achieved. However, on the heating front, unfortunately, things are not going in the direction of electrification, but the opposite. It's more focused on gas and reaching gas to all customers. But one positive news is the cooling sector. Around 1 million cooling split climas or other types of air conditioners are being sold, at least 1 million per year. And the government recently introduced the distributed generation regulation, which creates a good synergy or a potential if that can be used with cooling and solar PV. And that's, at least from the cooling side, given the Turkey's condition of cooling demand, it's a synergy which can also be in this part of the world, or these kind of countries can be utilized, I guess.
Okay. Well, thank you. I think we can summarize this first part of the presentations by saying that we have technologies available in the residential sector to solve the issue. They seem to be replicable. And the key question is how to speed it up. I would like to point also the audience to a project that runs in the Netherlands, but also originates in the Netherlands, but it's also European-wide. It's called Energiesprong, and it's pretty much what Guy, it's linked to what Guy has stated here. That's something that looks at large-scale renovation of existing buildings. And with that, we switch to the commercial sector more, where Torben von der Christensen will talk to us about the integration perspective of the vapor compression cycle and flexibility potential from it. So then hopefully you will also address the question of making it a business case.
Yeah. Yes, thank you. I come from Danfoss cooling segment. Thank you for that. From the Danfoss cooling segment, and I will talk about the vapor compression systems. Vapor compression systems, we don't call them that, but vapor compression is actually what is behind a heat pump. It's a compressor that compresses a gas where you basically then can split a medium temperature up to cold and warm. It's what's in your fridge at home also. So it's cold inside your fridge and it's warm on the back of the fridge. So it really is a huge energy consumer. It uses electricity, and it uses up to 17% of all electricity globally, and this is increasing. The interesting thing is that normally you are not realizing that you are only utilizing one part of that system. Normally you would only utilize the warm side, or you would utilize the cold side. So a big loss. On the other hand, a big opportunity also to go for and utilize both sides. I will go fast through this. So this is an example here. Sorry about it, it's a little bit small. I hoped it would be a bigger screen here. But this is an example on how we could do that, actually. This is a supermarket, and it has been done also. A supermarket, you see here, let me just see here. I don't think there's a pointer, so I will go here. Where you see in the heart of the supermarket, and by the way, supermarkets in a country like Germany uses up to 2% of all electricity in the country. So more or less virtually, you have your fridge, also another one standing in the supermarket, each of you. But what you can see here is in the center of that supermarket, you have a compressor pack standing, providing cold and heat at the same time. Normally, 95% of all supermarkets globally, they don't utilize the warm side. They basically throw it away, even on a cold winter's day. So this is the message here, that what we should do is to make this system here much, much more flexible. We have to utilize the heat in the store. You can do that for heating the store. You can do that for also for additional cooling of the store here. And you can basically also store your energy. This is the case where you store your energy in the ground. You can do that, but you can also connect to district heating systems where you can supply extra heat for the local community here also. So this is what we call the energy store. What you can do more is actually, because you are running with temperatures that you control within a temperature band, you can, on demand, you can slow down your compressor capacity. If the electricity utility is asking for lower electricity consumption, you can actually, within a few seconds, you can reduce your compressor power also. And that can be because the supermarkets, they are normally organized in chains, it's relatively easy to have big agreements, so you can aggregate these kind of quite large numbers also. So that is actually, the interesting thing is that it's actually doable. You don't have to go out and buy totally new systems for doing that. What you can do is just to connect to the system, change some of the controllers, and you are more or less up running with a lot of the systems, which are, of course, because they are big, they are quite expensive also. So you don't just change them every year. Normally they have a lifetime of 10 to 15 years. So that is the message here. It's also that it's not only supermarkets, it's also data centers, it's airports, it's everything which are connected to the electricity grid, but at the same time somehow misses to be also connected to a thermal grid. This is a way that you can, using the thermal grid also, make a big amount of storage. Basically, in many places, the storage facility is already there, because if you already have thermal grids, they are usually already have a lot of thermal storage capacity here also. Okay, I want to show you something else which is not very commonly known. It is an investigation that was made on again on the supermarkets on how much of their available compressor power do they use during 1 year. During 1 year, this is a 24-hour average consumption pattern here. What you see is that as an average, during the night you use 20% of the capacity only. And during the day it's only around or below 50%. It means that during the year it's around 70% of your available power capacity you are not using. So in a flexible electricity grid connected to a thermal grid, you actually have an installed base already which could be used for demand response and for providing thermal energy storage also. So it's a huge opportunity. We just have to take it and to work with it. What we did was also to do a lot of simulations on how is this really going to become real. It's also why I asked the questions about pricing of flexibility. If you want to do storage, if you want to do demand response, and you want to do these installments, even they are very modest, then it needs to pay off also for the supermarket owners. Of course it has. So what we did was really to compare two scenarios, and it was based on the Danish case, where we say, well, we can have a more or less constant electricity signal, which is the case today, because most of the price is based on tariffs, not the raw price of the electricity. The scenario 2 is where you have a much more variable electricity price. So, for instance, if we have a lot of very cheap wind energy during a winter's night, it really has to be very cheap also to utilize it and not just curtail it. And then we tried to make different scenarios where we have a very old type store and a base store with heat recovery, a base store where we actually utilize the extra today non-used compressor capacity. We also add demand response and we add some batteries also. And the interesting thing here is really that, well, if you have the constant electricity price, it still pays off to invest in these things. But not that much, yeah. You can see a relatively small decline in the cost pay for the store. The interesting thing is if you start investing during the variable electricity price, then you will see the base store. The base store, well, that's not a good idea to have a very simple system then. But if you have a very complex system where you really utilize all these special things, features, where you can do the demand response, you do the heat recovery, all the things, then at the end it just becomes a very, very good business case also. But it's the hen and the egg here. And for sure, we need some very attractive electricity markets for the big market to move here. I think that figure shows that. But it's doable. It can be done today with the best available technologies we have. So I think that was the main message here. I think I've talked for the time I had here. Not going through all these things here, but one thing is to remember also the marginal investments are relatively small here compared to what you have to do otherwise. Okay, thank you.
Well, thank you, Tom. That is indeed interesting because it's also touching on this question of cooling that we have received already. So what do we do with cooling? And my first question to you, I would say, in order to do this, you need smart systems. So in your assessment, what share of the vapor compression systems can be considered smart enough today to react to such signals?
Only a very few, I would say. I said about, I would say it's less than 5%. Less than 5. There are some, I think, from very early time, some big industrial systems also who has managed, because they are unique systems that always has been connected to this price signal. Yeah.
Is there any comments from the other panelists on this issue?
No, just very short. I really found very interesting your numbers, and I must say, when I presented before, when I talked about these low temperature grids, I think one of the advantages is exactly what you say, basically that you can directly use the waste heat of aspects like supermarket, which is much more than I would have thought. So you can heat up to 100 to 200 apartments with the waste heat of a medium-sized supermarket, which I have not expected at all. And it can be technically and economically feasible and interesting to do so. So very interesting.
Then we have Wei and then Monica. No, Wei.
Okay. I'm from State Grid, Beijing Electric Power Company. My name is Wei Xiao. I will introduce Beijing, our experience mainly about coal to electricity. As to cope with the air pollution control, the Beijing decided to reform scattered household heating method using clean energy instead of dispersing coal for heating to reduce polluting emission. By the end of 2017, the total number of coal to electricity households in Beijing reached 1,040,000. 4,150,000 tons of coal burning can be reduced in each heating season. In integrated route aspect, the coal to electricity in Beijing urban area is mainly based on the regenerative electric heater. In rural areas, air source heat pumps account for 90%. I say about the cost. The electric heating cost during the 2017 and 2018 heating season without the subsidy by government. The average electric cost per household was 2,591 yuan renminbi. While taking the subsidy into account, the average cost was 1,079 yuan renminbi per household. Compared with the coal-fired heating and gas-fired heating, electric heating has a price advantage. Thank you.
I think this is a very interesting comment, and if you are interested in how to shift away from coal, you should talk to Wei a bit more, because this coal to electricity program that now the Beijing government and also other regions are implementing is moving coal-fired heating out of the market very, very fast and replaces it by electricity, and also guarantees more cleaner skies, actually, which is another very nice side effect. Monica, you wanted to add another comment.
I was very glad that you brought up both heating and cooling, because this session is focusing on heating. But if we're looking into the future and the climate change, the cooling demand will grow rapidly, and by using, for example, with the heat pump cycle, both the heating and the cooling side, you can make large energy savings. And I also want to bring it up to another level, both talking about system integration, but also about urban comfort. By closing the loop in the building or on a system level, you can also have a better outdoor climate in the city, which will be a driver for the future.
Yeah, I think that's very important comment, and I guess also the integrative perspective of heating and cooling and storing the waste heat, respectively the waste cold, in low energy grids or in higher energy grids. That's something that will create quite some need for thinking and for conceptualizing and for maybe even an adjusted legislative framework. We will now move on from this, maybe you could say a commercial, but also a city perspective, to industry, because as we know, industry is the last quarter of energy demand on a European, but also on a world level. And if we can't significantly reduce the energy demand in industry or make it green, then we probably will fail in greening the whole society altogether. So, Martin Hagen, what is your take on this?
Thank you, Thomas, for the introduction. I'm happy to be here, mainly because I have a question which I will raise. So we've heard about the challenge we have for the heating, and twice this morning we learned that industry has a specific challenge, is more difficult to address. So my question to you, who is actually taking care for this industrial part of the heating market? I'm looking forward to get more answers on this one in the next 2 days. Also, I'm working in the field industrial heating, and I'm not having the solution, but I would like to share some of my views or my perspective on the industrial heating segment. Before I start, I think 2 numbers which are interesting, which I haven't heard this morning. Internationally, we have 150 countries with specific explicit targets on renewable energies. We have 50 on renewable heating. That just stresses that there is really a mismatch which needs more attention. But let's look a bit more to in industrial heating. Oh, this looks different than what I expected. Anyway, not so much the need on this chart. If we look at the industrial heating, so in numbers, I've simplified this a bit. 1/3 of the energy, of the total energy, goes to the industry, and of this industrial heat demand, 2/3 are of this industrial energy demand. 2/3 are for heating. So don't worry about this complicated chart. It's just a very big chunk, and we've heard it's different. It's very specific. So I cannot define it because each industry has specific needs, but the industrial heating market in general has a few things in common, which I would like to highlight. So on the one hand, what it has in common is that it has large and constant loads. As Wolfram said, it's more or less constant over the year, and the individual loads are quite high. So if we're looking in terms of opportunities where to intervene, that's attractive because one intervention has a large effect in total CO2 emissions. Unfortunately, we have also some challenges. One thing is that industrial demands are very specific, so it's more difficult in the building sector. Basically, the heating demands are the same. Second, the temperature requirements are much higher, which limits the application, for example, of heat pumps and some other technologies. And most importantly, the challenge in the industrial heating segment is that we have an issue with the market, that it's very difficult to get data, like Wolfram said, on the macro level, how energy is consumed, but also within industry on the micro level, we have a very big challenge. So the market aspect of industrial heating is as such a very big issue. Let's see what comes next. I will surprised. Okay, I expected this also. Getting clean process heat, very simple. Okay, I added here something. We need competitive solutions. So this is very straightforward. How are these? What are the pillars of the competitive solutions? We have technology. Imagine this as being green, because I think the technological solutions are available to be improved. No question about this. But I would like to highlight on finance and market. You could put them together, finance and market. I take them apart because I think financing alone is not the issue. Again, as Wolfram said, institutional investors need to come in to accelerate the market on the heating, the uptake of improved heating systems. But even financing alone is not sufficient. Again, we have to look at the market. What are the market players? And unfortunately, sometimes there are no really these market players like the EUREC institutions from which we heard in the very morning. And so that the players being active, they differ regionally and nationally. So this is, again, a very big challenge on the market side. Underlying all this, for sure, is the policy that industrial process heating is just very, very rarely addressed, which leaves me with the questions, are we feeling comfortable with 2050, all things being done, and the industrial process heating remains the big question mark, or should we much more reasonably start thinking about it now to be on the safe side that this is not falling back on us in the future? One very brief example of solar process steam, that's what we do. I'm coming from the private sector. So solutions for industrial heating are available. That's a solar steam generation system, not powering, but providing heat to a pharmaceutical company at the needs which the company has, and reducing the fuel consumption of the conventional heat supply, which is a steam boiler, over the year by more than 40%. I'm not going to go into any technical details because I think that's not the issue, but what I want to highlight, technical solutions are available. The system is running for more than 3 years, but we have an issue on the market, how these systems, how these solutions, electrification is the same, maybe in some cases it's more reasonable, but how can we accelerate the solutions which are there already in the industrial market? And this is not about technology. Yes, we need to improve technology, but this is about financing and the market. So, some key messages again. Industry is the biggest heat consumer which we have worldwide. Country-wise, there is a difference. In Europe, it's around 30%. In other countries, in hotter countries, industry consumes 60% of the heat. Industrial growth is expected also in countries outside of Europe. So this big electrification is important. I'm excited about it, but I have questions whether electrification, industrial heating is working in Europe. I'm having more questions even how it is in for example, non-European, non-OECD countries. The industry has very specific needs. That's a challenge. They have complex needs, high expectations, for example, in terms of temperature. Yes, but again, solutions are available. It's not about developing new solutions, but it's about accelerating the available solutions which we have already today. So sector coupling, yes, it's an opportunity, but I see, and I'm not feeling comfortable, that I think there's a bit of bias. Getting the flexibility, yes, we need it, I'm excited about it, but the rest we should not forget. And at the very bottom, I would repeat, industrial heating is a very big challenge, but as I said, I think it's also a very big opportunity, mainly because every single intervention which we have in industrial heating just has the effect of, I don't know, hundreds of individual households, just of the size of the industrial heat demand. So this was, from my side, a very brief introduction to the industrial heating perspective. It's not an alternative. It has to go side by side. And again, the bottom line, I think the solutions here are also available, but we need to think about accelerating them. That's about financing and market. And as I started my little presentation with a question, I would like also to end with a little question to you. So who are the players, who are the institutions to take the responsibility, to take the lead, and focusing more specifically on industrial heating? Thank you very much.
Thank you, Martin. It's interesting to hear that also you say that we have solutions available. So my first question would be then, if we have a lack of focus and a lack of attention, a lack of recognition, in your opinion, what could we do to move political attention into this field, to create framework conditions that make this field to develop faster?
I think the key part is political targets, because political targets ultimately translate into action. I mentioned there are only 1/3 of the countries which have power targets have renewable energy, renewable heating targets, and hardly any has specific targets on renewable or clean industrial heating, even though it's just a very, very big chunk of the total heat demand. And this is one thing. And the second, the message just, I think, needs much more attention everywhere. In the showcase, I've seen 0 out of 17 innovations in the showcase today focusing on heating. So we just have to talk more about it, and the solutions are there. Let's get it done.
So maybe we all together should actually encourage IRENA to put a focus on heating in the next General Assembly to multiply these experiences.
I'm very much in line.
I hope you take this into the notes. I talked to Degar before this session, and he said that he has some experience and they have done some work on the electrification of industrial heating. So I would be interested in hearing how you see that from a Turkish, but maybe also from an international perspective, Degar.
Maybe I can start with the global one, because that's something we did together with the colleagues from IRENA. Based on the remap work of IRENA, we released a few months ago a global analysis of the industrial energy use up till 2050-2060. And when you look at that, the industry is one of the actually fast-growing sectors. No, it grows around 1 to 2% a year, and given it's a third of the global energy use, it's an important sector. But the solutions to decarbonize the sector was quite different in terms of the mix of technologies compared to other ones. And that is coming from the challenges which Martin has explained. There is obviously the first step of improving efficiency. I think that's unavoidable. And there, actually, the heat pump technology will play an important role, both electrification, but also being much more efficient than a boiler. And then the next step is, of course, the renewable heat. And that heat can be supplied either through electricity-based or biomass or solar thermal we've seen as an option. Geothermal could be one. And then there is very challenging remaining CO2 emissions, and that for that you need probably some CCS and other material efficiency improvements and so on. So focusing on these technologies, what we've seen in the study also was that industry is driven by its profits, obviously. So cost is definitely one issue. It needs to be cost effective, the heat generation technology. The second is you should be able to have access, so there should be a continuous supply to that technology. And when you look at those, actually in some sectors it becomes challenging. Iron and steel is one of them. It's one of the largest industrial energy users, and the technologies of electrification are being looked into, but they're all at early stages. Renewable hydrogen is one of them. The cost is very difficult at the moment, and it requires much more electrolysis capacity to be improved. So that's a challenge. Obviously, you can get the excess wind power or solar power to produce the hydrogen, but it needs to be continuous. So actually, you will need actual renewable capacity only dedicated for that. Relocation is one technology one approach we've seen. So relocating, which is already done in the aluminum smelters, they are close to hydropower, geothermal power plants, so cheap power. And we thought that could also be a strategy in the future to put large industrial plants in places where there is very cheap electricity, and then export that to other countries. But of course, that's a big change in the industry structure. So all these have its challenges. It's many options, and technologies are at different stages of availability, commercialization. But again, I think the main thing is how to overcome the cost issue of some of them, and for that, obviously, like we've said, the political consensus is important, phasing out of fossil fuels, commitment for that, and then policies to make these technologies available in a commercial way. So this is based on the study we did together with IRENA.
I guess this study will be available?
It is available already.
Yes, available.
Yeah,
so
yeah.
Please, if you want more details, talk to Degar directly or look at the IRENA website.
Yeah, IRENA colleagues. Actually.
We have two. Yeah, but we have two more comments here from Guy and from Martin, maybe in this order.
Yes, I would like just to add on the electrification of the industry. We see a lot of evolution in, for instance, in the chemical industry. We are here in a quite heavy chemical area where industry is going in its processes from thermocatalytic to, for instance, electrocatalytic processes, to plasma processes, and so on. So there is clearly a trend to electrification in chemistry sector. Of course, every process is different. I think is also mentioned. But we clearly need a cooperation between chemical, steel, and energy sector to cope with those differences. Because that research on the new processes where electrification is important is going on in the chemical field. There are sometimes at low TRL levels, technology levels, processes going on, innovations going on. We need to see how these fit with the energy sector, because there's also a part of flexibility linked to that. That's the first remark. Second remark is that apart from electrification, there are other opportunities of decarbonisation of that industrial heat. Which are, I think, you mentioned the technologies are available. I think even more technologies are becoming available also. I clearly agree that the cost issue is important because gas price is very low, so you have to compete with that. That's important. But on the other side, I will just give 3 short examples where new technologies come in for decarbonization of industrial heat. First of all, I think also mentioned geothermal heat. We see deep geothermal going into innovations with new drilling techniques, electropulse techniques, going faster drilling, reducing the risks, getting possibility of low cost and also stable heat provision towards, for instance, in industrial sectors. There's an evolution in innovation on geothermal. Second is for instance, concentrated solar power. Concentrated solar power is now especially mentioned in very warm countries. We see now companies here in Europe that are bringing concentrated solar power into, in fact, moderate climates, where they think with new designs, with new innovations, they can make it feasible. So I also saw the slide of Francisco in introducing concentrated solar power is coming down on the cost curve. So that's also a possibility. And finally, I think also in the field of heat pumps, we have also some innovations where much larger jumps in temperature level can be realized with new types of heat pumps, which are being launched onto the market now. So really making possibilities for process heat coming from very low temperature heat. So do not neglect the new innovations coming up in this field. Just 3 examples of that.
Good. Very interesting and extending the discussion. Martin, very brief, because we have to continue then.
Very brief, because we talked about costs. What I think is very important to make explicit, there are 2 projects, both have the identical internal rate of return, so being same feasible. It's being realized in the building sector, but it's not being realized in industrial sector due to investment constraints within the industry. But other investors would be happy to realize such projects. So it's important. It's not that they are in absolute terms too costly, but they're relatively too costly, for example, for the industry to invest. And to what my colleague just said, when I say the solutions are available, in order to realize the cost reduction of the other, like most importantly PV, this did only happen by market acceleration. So when I mean technology is available, yes, it's there, but cost reduction comes with market acceleration. Cost reduction will not happen in the laboratory. Thank you.
And I think that's what we have learned from PV and wind by now already. Maybe that is also an aspect that Avi can touch upon when he will talk now about the thermal storage-based grid balancing, the importance of storage, maybe large and maybe small. I think your presentation looks more at large, but keep in mind that also small-scale decentralized storage has an important role to play. Please, Avi.
Thank you. Does it work? Do you hear me? Yeah. Okay.
And while we wait for the presentation, we have 3 questions from the audience so far. So please use the Attentify tool if you have more questions, and then we will look at them after the presentation.
Okay, good morning. I'm dealing with renewable area since the late 80s, dealing mainly with CSP, which you mentioned, the solar thermal. Was in a team that built the solar plants in the US in the 80s, which are still operational today and produce power at 2 cents per kilowatt hour and sell it at 6 cents per kilowatt hour. So built in the 80s and still delivering full capacity today. Then I was in Soler, a company that built power plants in Spain. And eventually I came to the conclusion that without going to the next stage, we will not be able really to continue with the implementation of renewable energy. We have to find a solution. What do we do when the sun is not shining or the wind is not blowing? So the first thing to do is try to store the energy from the renewable resources. And the other thing is maybe to hybridize it, because at the end of the day, you want your solution to deliver the product the customer is asking for. If the customer is asking for a certain demand curve, you should follow the demand curve and not tell the customer, this is your problem to follow your demand curve. The technology provider should provide a solution to follow the demand curve in the most efficient way. So we were founded in 2012. We are now a publicly traded company, and we do have operational solution by now. It took us 6 years, an investment of $50–60 million to come to that stage. So how does it work? We store the heat in crushed rock. That's it. Physical process, not chemical, just physical process. So we load our storage from several sources like electricity, a turbine, a heat from a CSP plant. Whenever there is some available heat, CHP, an engine, we take the heat. We store it. Then we run water through piping through our storage and generate or industrial steam. Answering your question about industry, so we are delivering industrial steam. We are delivering steam for power generation at 500 and up, steam at 100 bars in order to operate a steam turbine. We deliver hot water, we deliver cold water. And I mentioned again what I said earlier, 60–70%, depends where you are in the world, of our demand is for heating or cooling. So this is the unit. It can go from, the concept goes from residential system all the way up to mega power plants, because it's all modularized. We have small, medium-sized, large-sized modules, and you take those modules, put them together, and construct a system following the demand curve, which is, as I said before, followed by, provided by your customer. So it's economic. I think we have to remember, if we want to implement massively and tomorrow morning, it has to be cheap. So in a relatively large size system, we go below €1 per kilowatt hour thermal. It's modular. It has a lifetime of 30 or more years. Actually, you don't do anything but heating and cooling of your rock, so it will work almost forever. We lose about 5% on a 24 hours period of our energy through the walls. Most of the time, it's a daily storage, so your losses are even smaller. It's a natural resource that we use. It's not lithium, cobalt, lithium-ion cobalt, and others that are eventually, I don't see how their price will go down. The only way is going up, I believe. And we hybridize, as I said before. What do you do if there is, in a solar system, a week of clouds? So we hybridize, and eventually we come up, it depends where you are in the world, Europe or Africa or Asia, but we can go as 60–80% of your energy demand is supplied by renewables, and only 20–30% by fossil fuels. And I believe by delivering such a system, we are already following our targets. That's the concept that we have here. A couple of case studies. Here we are talking, utilizing our storage for district heating, and I'm speaking district heating, which has a demand of 90 to 130 degrees. By the way, I like heat pumps, but I think there is no one solution. I mean, considering the disadvantages, if you district heating, you have to go higher temperatures. So I don't know that heat pumps can deliver those temperatures today in an efficient way. And the next thing you can do is really take the cheap power at night and deliver it in the day. And I think this is the concept we are following. So what do? We charge when renewable energy is available. We are very efficient because we store the heat anywhere between 600 to 700 degrees Celsius. So if you have a limited space, and we always have a limited space, we have a very efficient energy storage per cubic meter. And we don't have any pressure in our storage. The pressure is only going through the piping that we run through the storage. So this was a district heating, by the way, which could be turned on the summertime to district cooling. Okay, using absorption chillers, other technologies. When you store the heating, you can always use it for cooling. Another, maybe for you, Martin, application is, since we are storing 500 to 700 degrees Celsius, we can deliver steam at 180, 200 degrees Celsius, 10 bars. We can combine wasted heat going from some kind of chemical or other processes, which is, let's say, 130 degrees, and it's not good enough for industrial steam. We top it up with steam coming from electricity, and we can use this heat in our system. So it's a very efficient way of producing steam from the industrial processes. Of course, such concept can be used in smelters where you collect the heat, and there's a lot of heat there, and reuse it for generation of power or for any other purposes. So we are basing the fact that there is some curtailed or cheap power at night, and we use these numbers. I think it's numbers from Germany to 17, where cost of power going down to the 1, 2, 3 cents at nighttime, and there are 8 hours of this kind of low electricity spot market pricing. And if you compare, and there's always danger in giving numbers, but just for this case, you can see that with such a concept of charging the storage in the low electricity prices and delivering around the clock, you can go as low as below 4 euro cents per kilowatt hour, which I believe is a very competitive number already today. Where are we today? We are building our first 3 commercial projects, one in Israel, a couple of them in Israel. One is grid connected, will be grid connected power station, CSP power station, grid connected before year end this year. We are building 1 unit for CHP for New York Power Authority, the electric company of New York State, will be operational by next summer, and the 3rd one for the Israeli army. And we are able to deliver those systems today, and this technology is not an idea, is already ready to be delivered. And excuse me for the commercial part, but that's where we are. Thank you.
Thank you, Avi. You showed a big box, so my immediate question would be, how scalable is that? Can I as an owner of a 6-family house, for example, use that? Can I use it as an owner of a hotel like this? Can you scale it down?
Right now, it's already scaled up. We are building the first project, which is already being delivered right now in those 3 months. It's a 90 megawatt hour storage unit, actually a steam generator. One thing I forgot to mention, that we are replacing the steam generation unit. So there's a lot of cost savings if you implement such a system, which is generating the steam and is being used as storage as well. So how big can you go? There is no limit. We are talking now about projects in Italy of a few hundred megawatt hours for a large combined cycle gas station with a major utility.
But how small can I go?
Okay, that's a good one. The concept goes as small as the residential unit.
Okay.
The commercial guys are not allowing me to start with this. So yes, I mean, the concept, I see in a couple of years we will have a very small unit which you integrate in your house and take the power when it's cheap and use it around the clock for heating and for cooling. It's just a question of industrialization. It's not another concept. It's just building a smaller box.
Good. Thank you very much. That opens the floor for questions from the audience. We have 4 now, but before we go to them, I want to ask one question to my panel, because originally I wanted to ask if you think whether the technology in the sector is ready to allow for meaningful electrification of heat. And I would like to understand if you think that this potential is used. But since Avi mentioned the end consumer, maybe I'm more inclined to ask, do you think that the end user, the respective end user in residential, industrial and commercial applications is ready for the electrification of heat? Does anybody have a first intention to answer? Guy?
Yes. Well, I think the consumer is ready, but there are still some market signals that are not there for the consumer. I think that's clear. When we made an analysis in Belgium of installing 250,000 heat pumps in the residential sector, what the impact would be on CO2, on extra installation capacity for electricity and so on, we saw clearly, of course, there is a CO2 reduction potential. If you're going to add active demand response on those heat pumps, there's clearly a positive effect on system level. You have 15% additional CO2 reduction by active demand response, so in fact the coupling of heat and electricity in that sector. You have a better CO2 abatement price, meaning the price you pay per CO2 reduced. So it is better because you are having less curtailment of renewable energy, because you have to install less additional power plants for peak generation capacity. So all those effects are clear on system level. The difficulty is when you arrive at individual level, because what is happening when you are doing, for instance, active demand response with heat pumps, it is that, for instance, you perhaps increase a little bit your average temperature during the year in your house, because you're playing with that temperature as flexibility. And so you have some extra heat losses. And this means that on end user level, you have some extra consumption, so some extra costs. So the global benefits are reflected on individual level for extra costs. And you need to, in fact, break through that, in fact, contradiction. And this can only be done, I think, by, of course, you have variable tariffs and so that can be introduced, and which reduce, of course, the use-based price that a consumer paid. But you also have a lot of not use-based tariff, so distribution tariff, grid tariff, and so on, which also needs to be tackled. And that's why we believe that there is a big importance of local energy communities and how they can exchange electricity, heat, well, electricity, especially electricity, between each other at cost-reflective tariffs. That's an important. We see local energy communities coming up as a terminology in the European legislation now. It has to be translated into national legislations. So local energy communities exchanging energy between each other, and how to make that cost reflective, that's a very important challenge, to have all those end users coming along. I think that's a little bit the story or the storyline behind it. We are in Belgium are now working together with 5 different local energy communities to see where they bump into legal barriers, economic barriers, and that we can make proposals to change that situation. Sorry
Thank
for the
you.
long explanation.
No. I think that's fine. Thank you. And then maybe Torben, you have two questions directly addressed to you. You can have a look at there, but maybe you can also comment on whether the cooling sector in commercial applications is ready for for more electricity and heat and cooling in this case.
Yeah, sure. This question about the food quality when the supermarket should provide demand response, that will be no problem because today already all kind of temperatures are controlled. So you're operating within a safe band of temperatures. And of course, the temperature and the food safety will be king of the systems anyhow. So that is already dealt with, you can say. And concerning what you asked about, Thomas, about the how ready the users are, I think they're very ready. From our experience, they are. It's always about the business case at the end. And then we are back to the remuneration of flexibility. Also, the reality is that the remuneration today of flexibility is extremely low, and we also have had a eco-design preparatory study showing that actually. So that is really a big dilemma. I think it's still because we have a lot of coal-fired power plants running, which is a kind of backup because we, for all cases, need the stability in the grid, so we are not taking them out. The day that we are taking these coal-fired power plants out, then there will be, then we will have to jump into the deep water, and we will have also a high price on the electricity when we have a high demand and a low production. Yeah, I think, and my final comment, it was the previous question you had also, how much are we ready for the heating? I think in some countries we are, unfortunately, also in my own country, we are suffering from a lot of locked-in investments. Especially, we have a lot of plants that are supplying heats today based on fossil fuel. And these have a lifetime of 30, 35 years, even more sometimes. What are we doing with these plants? At least we should start and say we are stopping investments in such things and moving into medium-sized, big, decentralized heat pumps or whatever it could be. Yeah.
Again, a number of good points. I hope you take good note. Is there anybody else on the panel that would like to comment on these questions or pick up what has been asked? Maybe we give Monica the floor, and then Digger, and then Wolfram.
I think it's a good timing at the moment, and I think the end users are more ready now than they have been before. I think digitalization could opens up for new business models for electrification in the heating sector. Maybe it's time to sell a climate in an apartment instead of selling technology. So I think it's a lot of possibilities to take care of, and it's also when it comes to flexibility. With system integration on building or on grid level, it's possible to both save energy and add increased electrification and renewables.
Thank you. I would like to put a perspective from what the current Turkish grid is actually suffering. So if the grid is ready, that's the part which I want to talk about very briefly. Turkey is, I think, 8th or 9th largest steel producer in the world, and around 2/3 of that is coming from the electric arc furnace route. So that's the electricity using steel production, and there's about 45 steel plants running. The problem is that they have huge deviations in their production, which also causes, in certain times, also in a very little amount of time, very large deviations in the load. And when that is combined with other changes in the load, puts a big stress on the grid security and reliability. And how currently Turkey tries to overcome this is as part of ENTSOE, uses the interconnectors, which is anyway only 3, with 2 with Greece and 1 with Bulgaria, and tries to balance the flexibility issue like that. But this is not sufficient, because sometimes in less than a minute, there is 1 gigawatt power flow in these 3 connectors. And their capacity is anyway around 1.2 gigawatts, so import-export. So that's already an issue on flexibility. And the government policy is to reduce the share of gas in the system because of energy imports, because it's all coming from other countries, and replace that with coal and some solar and wind, and then the flexibility issue will even become a more problem. So we can, of course, say in Turkey, let's electrify more industry, heating, cooling in the residential buildings, but then how will the grid, is the grid ready? Are they planning for it? So the transmission system operator is actually suffering quite a bit on this.
Yeah, I would like to go back to, let's say, the industry on the one hand and as well your storage on the other hand. And I think in order to, or let's say, I see 2 aspects. On the one hand, how can I make the industry itself more efficient and more renewable? That is one point. Obviously, you're usually, I imagine, talking to the customer is your industry and they're thinking about their own process and that's it. On the other hand, I think how can I integrate my industry better in the region, and how can I make the overall system more efficient? And I think there, with both systems as well with storage, in combination with district heating and cooling systems, we really gain possibilities. You gain possibilities on the economical side and on the energy side, as you can use energy more on a longer time, on more hours, and on different temperature levels. And therefore, I think there's still quite a potential which is not by far fully used.
Thank you. Yeah, Martin, please.
I think one aspect which was missing so far is what can be done on the heating sector regarding of the solution, electrification or any other, is to lower the development costs, because from my understanding, all on the power sector for the end user, let it be private or commercial industrial, it's more straightforward. You compare your power bill. But for the heating question, again, we have the challenge. It's very difficult because the data availability is limited. And this is one phase where I think there's a need for more public intervention by accelerating, for example, data collection through energy monitoring or auditing, which in the end will make it easier for any solution, any which was mentioned so far or any other, to get into the market. But everywhere on the individual level, studying whether this case is sufficient, whether this case is feasible or not, already creates much more investment than just, for example, switching to a green power supplier. So we need more data, and we need, I think this is something where the public sector has to take a responsibility to push the private sector, say, okay, get more data, we will make use of it we'll make use of it in the next years.
Well, this is indeed a very important point that has been picked up by the current legislation. We see also on the screen a question of what about the legislation on the energy efficiency of buildings. And for whoever has asked that question, didn't give his name, but have a look at the current energy performance of buildings directive, the latest one, the one that is revised and is in force since June 2018. Because this one is mandating renovation plans for all member states of the European Union. And I think that is really something that should be multiplied across the world, because these renovation plans also include a necessity to document on the energy demand and to document the share of renewable energy that is used in buildings, and especially in renovation buildings, because most of us will agree new builds is no problem. Renovation is a problem. And we have touched upon that. We need an industrial style, mass-produced renovation process. The people from Energy Sprong that we had at our conference, they said we have to renovate probably 3,000 buildings per year, depending on which system boundary you draw. But it is a tremendously much bigger number than what we are renovating today. I guess that's what we can agree to. Then Avi, please.
I think to comment, in order for things to happen, you really need at least 3 things. First, if there are system gains, as you mentioned, they should be transformed for the final customer, user. Otherwise, why should he do it? Why should he bother if it's just excess cost? So this is one. Number two, if there are real production cost of power for renewable, let's say wind power at night and so on, if they are really cheap, reflect it to the final customer. Don't cover it with a lot of other grid costs and others that are already there. And so the customer cannot enjoy the fact that you are curtailing power at night or power is very cheap at night. So this is the second thing. Reflecting the production cost to the final customers. So he have an incentive to do some changes and use some measures to save or to transform his energy needs from, let's say, from day to night. And the third thing, there is a political will. I mean, just heard the story from South Africa where we are dealing with the area of Durban right now, and there is a political decision there to stop as much using coal. And the target there is try to make all industrial steam boilers electric, and the electricity should be delivered at cheap electricity timing at night. So things are moving very fast. I mean, things will happen within months there. So this is in South Africa, in the Durban area right now. But this is so these are the things that I needed: a combination of low, cheaper incentives for people, industry to be used, and then putting some muscle and putting some price tag on polluting. That combination probably will make things happen, and it could happen very fast. Very fast. Everything which is fast is 10, 20 years, but it could start happening tomorrow. This is what I hear, and not just putting targets without knowing how to fulfill them.
But that is a very important point, and that is also worthwhile noting down, that we are discussing a very traditional, very slow industry. So I think it's really, that could be one of the outcomes of this panel, to say whatever we think we can do fast will take 20 years. Torben.
Reaching the target will take 10 years, but doing it can be done tomorrow morning.
Some questions up here. First of all, there was something about the compressor efficiency and who should really ensure that these systems are running okay. I think there is or there will be already now happening a huge transformation in the business models in the market also, because I think the question is actually very relevant. I think if you look at many installed systems today, they are definitely not running at the efficiencies that you would expect them to run at. So in that sense, it's actually very good to have a much more, system where the owners of the systems, they rely a lot on that systems are performing as they should do, actually. It has to do with installment, first of all, also capacity calculation regarding the need, and also the maintenance of the systems. And the other thing is that the thermally driven systems, there is I think you are talking about absorption systems here. Normally they are, I think, again, it ends up in a cost performance issue. Again, if you want to pay a certain amount of money per kilowatt capacity, then normally your deal falls out to vapor compression systems here. And then in many cases also we are working with high temperature differences. If you go from minus 20 to plus 40, something of an absorption system that has to cover with that. Yeah, I think.
Thank you. I want to prepare my panel ready for the last question I would like to ask all of you before we close. We'll not do that yet, but so that you have some time to think. Before you go home, I would like to understand if there is a wish list and Christmas is coming. It's very soon. You can buy speculus in the supermarket, so this will be soon. So what's your wish to policymakers? If you had one wish, what should they change to make all this a reality and to accelerate the speed? And then I would like to maybe touch upon one other thing. What can we do before we ask the policymakers for a wish list, before we ask decision makers to do something? So what can we do as industry? And I'm asking that because EHPA, my association, we are members of an initiative called Decarb-Heat. The idea is to say, as industry, we have so many solutions and we all run into the same, it's by and large the same wall that we run into. It's cost, the business case, flexibility is not valued enough. So what do you think we can do as industry, and are you doing it? Are you approaching policymakers yourself and say, look, this is the change that we need, and you have to change the legislation in a certain direction? What can we do there? It's still a democracy here in Europe, so we should be able to vote in a certain direction, no?
So I would like to start with your first question, actually. Let's say one direction I see, or I always like simple answers to difficult questions somehow. And I myself come out of a technology sector, and many engineers fell in love with their own technologies they have been studying or working in since many years. We had a talk about a dinner yesterday about nuclear power plants and a toy for engineers to play with them. I think we should go, with regard to legislation, towards solutions which are technologically open. So one very basic thing which started in Europe, in some countries very well, but only in a few and only a little bit, and I think it could be much stronger, is shifting other taxes to a CO2 tax. So it's a very basic decision, but once you shift it to the CO2 tax, it's just, the customer itself starts thinking about what is the solution which is most CO2 efficient, and that's it. And then the best technology will win, and it will be one case one and the other case other. But it's open, it is flexible, technologies can evolve over time, and as well in the storage sector, I think it's the same. When you ask for a need additional capacity for the grid, you close your way to storage, you close your way to demand-side management, you close your way to active customers. And I think that is a lot of opportunities that we lose. Actually, you don't ask for additional capacity. What you ask for is, okay, we have a certain problem. What is my solution? I need a flexible system. That might be capacity, but it might be storage, but it might be as well active demand-side.
I totally agree. I think if we would tax CO2 much more, the energy mix, the actual energy mix would reflect a much higher variability in price. And that is actually what we need to make the business case around flexibility. Then we can just keep all the old coal-fired power plants, because when they are used, then the price of electricity will also be very, very high.
What I would ask from politicians would probably be, hey, do your job. First, set a target for the price you're willing to pay for your demand profile. I'm having 10 years fight with the Public Utility Authority in Israel. Don't tell me which technology to deploy. Tell me how much are you willing to pay as a top for the product that you need, okay? So finally, it's coming to an end, and hopefully within the next few months, 10 years fight, just so those guys will not choose a technology, whether this is coal, gas, or any other nuclear or whatever toy. Just say how much are you willing to pay, and then place a bid. And whoever is having the best price should win. So this is one thing for the politicians. And the other, allow and really push for putting pilots in your own country or your own region for new technologies, and even subsidize it in a way so people can see the new technologies coming in. Otherwise, 95%, I would say, of new technologies are dying in what we call the death valley. They never come to reality because they want your new technology to be as safe, as proven as a commercially available technology. Can't happen. So politicians can help by setting up pilots. And things are happening this way, but it's a huge fight for new developers of technology to come to the market.
Before you continue, I gave biggest mistake of any moderator: never give the microphone away. Done. Again, tick it off. For the rest of the panel, maybe, because now we're coming to the industrial side, there is one question that is always asked again and again. People tell me, and I guess many of you too, we can't electrify everything. So what do we do then? And the question is here. So what's the role of green hydrogen / green gas, and what do you think about that? maybe in terms of cost and efficiency, because technically it's feasible, but will it be cheap and will it be efficient? And I guess for Martin, this intervention comes at the right time, because you could touch upon that, I guess.
So I definitely see a role for green hydrogen, because ultimately we have to decarbonize as much heating as possible, and it's really a lot. And electrification alone will not work, especially not for the or for some sectors it's more difficult. So there I see a big role for green hydrogen, for example, because also the solutions like solar thermal, which I mentioned explicitly, or geothermal, have challenges at some point in the temperature, for high temperature. So yes, I see a very big role. Now coming to my wish list, since Avi already got the target wish, I participate there. But my specific additional wish is to really think more on how we can make the heating a market. And there are a lot of things how this can be accelerated. Again, it's technologically neutral. One thing was being said again was accelerating by showcases, building trusts, reducing development costs was also said. And yeah, I think this was the key message. One I missed, maybe I have to chance again. Sorry, I have to pass by.
On the power to gas issue, well, I think you cannot consider power to gas as a standalone solution. You should look at it in a system perspective again, which is crucial. There are several power to gas projects, pilots running. I haven't seen that much which really have the full business case. Of course, we're looking at a longer perspective. We're looking at 2030 and so on. That's, of course, we see decrease in the electricity prices for renewable energy. We see an increase of the fossil fuel prices probably. So there is somewhere in between that period where it meets, and when those type of applications become really feasible, economically feasible. But as I said again, it is all a question of comparing different value chains on system analysis. For the moment, we are critically looking, for instance, at the situation here in the North Sea. North Sea has a lot of wind power potential. And of course, you have quite a lot of demand from industry, from private end users on a heavily, densely populated area going from north of France, Belgium, the Netherlands, Germany. And the question is how to bring all that renewable energy into the energy system. Is power to gas one of the solutions? Well, it should be looked upon with a real comparison of value chains of different possibilities. For instance, what are you going to do? Wind on sea. Are you going to transform that directly into hydrogen and transport the hydrogen as molecules to the shore with existing infrastructure, gas infrastructure? Are you going to transport it with AC, DC lines? When it comes on shore, what are you going to do with that renewable energy? Are you going to put it into the industry? Power to products, for instance, which is, for instance, power to methanol is one of the cases critically looked at. It can transform global maritime sector transport fuels, for instance, renewable methanol. There are other chemical products. Are you going to transform it into hydrogen and put it into the gas grid? Are you going to store it into batteries? So you need to compare all those value chains really based on that specific energy system, taking into account the distances of transport, taking into account which companies are available over there, which demand is there. So this is a very specific study that needs to be done to answer that question.
And you wish?
Sorry?
You wish from policy?
That's what we wish from policy, that they support that type of study, yes.
Okay, thank you. Wei? No? Then Monica, please.
that policy continue to set aggressive targets and also makes it technology neutral and try to move from have a system perspective and move from technology driven to more demand driven. And I think it's in agreement with this, looking on the different value chains.
Thank you. Decker, please, yeah.
Okay. Maybe just to add one small thing on this little question on the hydrogen part, on the cost side. There's a lot of studies being done on this, on how much hydrogen costs from electrolysis route. Obviously, it's a cross-cutting technology which offers a feedstock option, iron and steel, and so on, high temperature heat. The thing is also about how much more capacity we will still need to be able to reduce the cost of that hydrogen. So today, around electrolysis capacity from alkaline, I just looked up in the morning, it's 25 gigawatts, I think. And there are studies which show you need at least to go 100, 150 gigawatts of installed capacity of electrolysis to be able to reduce the cost of generating hydrogen with cheap electricity and full load hours of operation and make it competitive with other types of fuels. And that requires 20, 30 years still to come. So that's also the scale of the challenge I think the industry sector is facing. And on your other question, perhaps this CO2 price was mentioned. Of course, we don't know how realistic it will be in the short term to have that international price. But given that industry is generally many companies in many different countries having plants, the sectoral approaches, voluntary agreements have also shown to be effective in the past. Cement industry had one example, aluminum industry. So bringing these different industry players, businesses, and working towards a goal of electrification, which also support their business interest, could be one way of engaging them, like in a sectoral way. So that's the sectoral approach, which I'm trying to explain towards electrifying the industry sector. So.
Well, thank you very much. I have been asked to keep the time, so I guess I will not allow any further questions because we have been running over already 5 minutes, so maybe you can do that bilaterally. I would like to summarize this.
I have a comment, actually, and I could not access to Attendify. Can I just summarize it?
You get 30 seconds.
Okay. Okay. So, okay, thank you. So I bring out the gravity of cooling energy problem. You know, IAEA projects India will have 1 billion air conditioner by 2040. The World Energy Outlook projects China will have cooling energy demand of China by 2040 will be whole Japan's electricity demand. So my comment or suggestion is, since IRENA is an international organization, maybe next year it could focus on cooling energy a little more.
Thank you for that. We have been trying to push IRENA to focus on heating first. So now what I can tell you is that in a European perspective at least, 50% is heating and cooling, but 45% of these 50 is heating. So if we don't solve the heating challenge, cooling will not do anything to solve the issue. Of course, it's different from country to country and from region to region. But I think what we have heard this morning is that an integrated perspective will also be very helpful. And that's how I would like to close, because no, I cannot allow that. You can continue this bilaterally. I think we have had a very inspirational session. At least from my perspective, the major points were tackled. We need to address the market. We need to introduce a price mechanism to challenge more broad thinking about the problem, because this will bring the problem solution capacity into the end user. That was also mentioned in some of the speeches. The end user is not only us as end users in buildings, but it's also decision makers in commercial and industrial applications. And this applies worldwide. So honestly, I am convinced that what we have here as solutions can be deployed on the world level in a positive manner. We are able and we are capable of solving the issue if we take the cost situation into consideration, and if we recognize the timing. Because that was also, and I can only repeat it, this is a slowly moving industry, and it's getting even worse when we talk about industrial applications. So we need to start deploying, and we need to start setting aggressive targets in order to achieve something over the next 32 years until 2050. Thank you for your attention. If you have any further questions, I am really convinced, I was not just saying it, you have a truly capable panel for a lot of answers in this field. So please use the opportunity in the next 2.5 days to engage with them and to start a discussion. Thank you very much.